Hello calculus students, and welcome to 5.6 inverse trig differentiation. So we're going to take all of our inverse trigonometric functions and we're going to take the derivative of them. What I'm going to do to you is I'm going to prove the derivative so that you don't just think they're coming out of left field. You'll see where these derivatives actually come from. Okay, and then of course we'll be able to apply the chain rule to these derivatives as well. But for right now I'm going to just do the most basic sense derivative of inverse sine of x. And then we'll see how that goes. I might do a couple more. So, in order to prove this, I'm going to say I have a function y equals inverse sine of x. Okay? Knowing properties of inverse sine, if I took sine of both sides, that would tell me that sine of y is equal to x. Okay, this is a true statement. And if sine of y is equal to x, that means that there is some triangle with an angle y that has the ratio of x opposite over 1 hypotenuse. Okay, because sine is just opposite over hypotenuse. So sine of this angle y is x over 1 opposite over hypotenuse. With that said, we can find out the third side of our triangle using Pythagorean theorem. 1 squared equals x squared plus, we'll call this a squared. And solving for a, you get a is equal to the square root of 1 minus x squared. So down here, I don't know if you can see that over there. Down here, we just have the square root of 1 minus x squared. Okay, and that's going to come into play later on. So back to here, my goal is to find dy over dx. Okay, I want to know the derivative of this function. So what I can do is I can implicitly take the derivative of this. And it's nicer to take the derivative of this is because I know what the derivative of sine is. I know what the derivative of x is. Whereas looking at this function up here, I don't know the derivative of inverse sine. So I kind of move it around to make it something that's familiar to me, and then I can take the derivative. Derivative of sine of y is cosine of y. Implicit differentiation says I need to chain on dy dx since y is a function of x. So essentially this is my answer right here. I just don't know what it is yet. And that's equal to the derivative of x, which is 1. Okay, we are almost finished actually. What is cosine of y? Well, here's y. Cosine is adjacent over hypotenuse, so it's square root of 1 minus x squared over 1. And solving for dy dx, I get 1 over 1 minus square root of 1 minus x squared, which is what we were trying to prove in the first place. So dy dx is equal to 1 over 1 minus x squared. And that's a proof that the derivative of the inverse sine of x is that. Alright, very good. I think that you can do inverse cosine on your own. Okay, and in fact I think I told you in class that I want you to do inverse cosine on your own. Okay, and hopefully you can come in tomorrow with that done. But I think we'll do inverse tangent together.